Meetings to respect faculty. My name is Muskan and I am from CSE AI&ML section. So I am going to present a topic called design and implementation of a full wave rectifier for efficient power. First of all, I just want to introduce this topic. That is a full wave rectifier is a crucial electronic circuit design. It is used to convert the AC circuit into the DC circuit by utilizing both halves of the AC cycle. So here the full wave rectifier, it is a circuit design and it is used to convert the alternating current into the direct current by using the both halves of an A cycle and by employing multiple diodes. Either it is a center drop configuration with the two diodes or in a bridge configuration with four diodes. A full wave rectifier ensures that the output current flows consistently in the same direction regardless the input AC phase. So this is about the introduction of this full wave rectifier. And next, coming to the objectives of the full wave rectifier. Here it there are certain objectives of this full wave rectifier. It is used for understanding rectification principles and comparative analysis, circuit design and implementation, performance evaluation, next practical applications, and then simulation and expertization. Understanding rectification includes it also includes the understanding, and it also includes rectification values. And next, coming to comparative analysis, and next it is very much important for circuit design and also for implementation, performance and evaluation, practical applications, and then simulation and experimentation. So slowly, slide by slide, we can discuss about that. Next, coming to the key features, there are certain key features of this full wave rectification, that is efficiency, reduced ripple applications. Let's discuss a side by slide, that is what is efficiency. In a full wave rectifier, are significantly more efficient than half wave rectifier. It is used in achieving 81.2 compared to the 40.6% of half wave rectifier. So here half wave rectifier, it is the efficiency is 40.6%, whereas coming to full wave rectifiers, its efficiency is 81.2%, and it forms ability to utilize both halves of the AC form and resulting in a higher average output voltage. So efficiency, this full wave rectifier, it is used in resulting a higher average output voltage. Next, coming to reduced ripple, a ripple factor for full wave rectifier is lower, and that is approximately 0.482. Then the half wave rectifier is about 1.21. Here, which the ripple factor whose rectifier is low, that which is you, it leads to the smoother DC output. So here the rectification of reduced ripple is a full wave rectifier is a 0.482, whereas less than compared to the half wave rectifier. So it is used to convert the smoother DC output, which is dangerous for sensitive electronic applications. Next, coming to the applications, there are full wave rectifiers find widespread used in power supplies for electronic devices such as televisions, radios, chargers, whereas reliable and stable DC power is essential. So these are the few key features. Just now I had discussed, that is efficiency, reduced ripple, and also applications. Next, coming to the basic working principle, the working principle of full wave rectifier, it involves AC current converting in AC current into the DC current by utilizing both halves of the AC form. And in this process, it also involves use of diodes, which allow the current to flow one direction while blocking it to the another direction. It is a basic working principle of the full wave rectifier. Next, coming to the slide, working mechanism. The working mechanism includes input AC supply, diode configuration, positive half cycle, then coming to the negative half cycle. Let's elaborate each and every topic. What is input AC supply? Input AC supply. The full wave rectifier is connected to an AC supply, which typically has a sinusoidal waveform. The first step involves using a step-down transformer to reduce the high input voltage to a lower, manageable level suitable for rectification. It is a full wave rectifier. It is when connected to an AC supply, and it is a typically it's a sinusoidal waveform. It also includes the first. It also includes the step-down transformer, and it reduces the input voltage to a lower manageable level suitable for rectification. Next, coming to diode configuration. Diode configuration means there are in a full wave rectifiers, implemented in a two main configurations, that are the center trap and bridge rectifiers. So in a diode configuration, in a full wave rectifier, there are two main configurations which include center trap and bridge wave rectifiers. So what is the difference between center traps and Bridge wave rectifier is center trap configuration. Two diodes are used and each connected to one end of the transformer secondary winding with the center trap serving as a common ground. So in a center trap configuration, there are two diodes are used and each end of the diode is connected to the secondary winding and with the trap serving as a common ground. Next, coming to the slide that is about positive half cycle. So far, I had discussed about input AC supply, and then I had discussed about this DC configuration. Then I am going to discuss about positive half cycle. Positive half cycle, during the positive half cycle and AC input, the upper terminal of the second winding becomes positive, while as the lower terminal of becomes negative. So during the positive half cycle, the first winding, that is the first primary winding, becomes positive winding, and then the second, then the lower terminal becomes negative. Here in the center trap configuration, diode connected to the upper terminal, that is called as D1, becomes forward bias, and then the other which is connected to the lower terminal, which is converted as the reverse bias. In the bridge, whereas in coming to the bridge configuration, two diodes conducts allowing current to flow through the load in only one direction. So this is about positive half cycle. So far, positive half cycle, here the upper terminal is connected to the positive end and the lower terminal is connected to negative winding. The terminal which is connected to the positive winding is called as forward bias, and the terminal which is connected to the negative winding is called reverse bias. And in configuration, two diodes are used, which is allows current to flow in the only one direction. Next, coming to the negative half cycle, it is slightly opposite to the positive half cycle. Here in negative half cycle, the upper terminal of a secondary winding becomes negative and the lower terminal becomes positive. Whereas which is the upper terminal, which called as negative, used as a reverse bias, whereas the lower terminal, which is connect becomes positive, comes to the forward bias. Here in the bridge rectification, D3 and D4 conduct, again allowing current to flow through the door in the same direction as during the positive half cycle. So there are something similarity between positive and negative half cycle. Positive half cycle, it includes the upper is connected to the positive and lower is connected to the negative. Upper is used as forward, lower is used as negative. Whereas in negative half cycle, here lower is terminals becomes positive and upper terminals becomes negative. Lower terminals connected to the reverse bias, sorry, a forward bias, and the upper terminal becomes to the reverse bias. This is a similar minor differences between the positive and negative half cycle. So next, coming to the types of full wave rectifier, there are two types of full wave rectifier, that is center trap full wave rectifier and bridge wave full rectifier. Center trap full wave rectifier is during the positive half cycle of an AC input, one diode conducts while the other remains reverse biased, and it's allowing current to flow through the load. And conversely, during the negative half cycle, the roles of the diode switch, ensuring that currents continues to flow in the same direction through the load. Whereas coming to the bridge full wave rectifier, during both halves of the AC cycle, two diodes conduct at a given time, allowing current to flow through the load in a one direction. And this configuration effectively utilizes both halves of the same waveform for rectification. So these are about the types of full wave rectifiers. Next, coming to the circuit diagrams. Here I had presented two circuits, one circuit with full wave rectifier without filter and the other circuit with a with filter. So let's discuss without filter. It is I had used multi-sieve and I had connected to the series. When we run the program, sorry, when we run this simulation, we get here, see, this is the output when it connected to the full wave rectifier without filter. When I have connected to the full wave rectifier with filter, so this is the output. The difference between them is the running waveforms and sinusoidal waveforms, which changes with filter and without filter. This is the difference between them. Next, coming to the applications. So what are the applications of the full wave rectifier? It is used to power supply circuits and then battery charging, then DC motor drives, then signal demodulation, coming to voltage multipliers, electric welding, and LED lighting. There are certain applications that I have presented in front of you, that is power supply circuits, then electric welding and LED lighting. So far, I had discussed about this full wave rectifiers topic. That is, I had introduced the topic. I already told, like, full wave rectifier is an electronic device which is used to convert the AC current into the DC current by utilizing both halves of the AC cycle. Then I had discussed about the objectives of this full wave rectifier. Then what are the key features? Here I told about efficiency, then reduced ripple application. I also told full wave rectifier has more efficiency compared to the half wave rectifier, and it means the half wave rectifier has full wave rectifier has double than the half wave rectifier's efficiency. Then I had discussed about reduced ripple. that is the one with a low reduced ripple has smoother DC power, that and that is full wave rectifier has more smoother reduced ripple. Then I had discussed about application. Then I had discussed about basic principle. What is the principle of this AC full wave rectifier? It converts AC current into the DC current. Then I had discussed about working mechanism. I had discussed in this input AC supply diode configuration about positive half cycle, and then I had discussed about negative half cycle. So similarly, positive half cycle is something different from the negative half cycle. That's all about that. Then I had discussed about types of rectifiers, that is two types of rectifiers I had discussed, that is center trap full wave rectifier and then bridge trap full wave rectifier. Then I had shown you about the circuit diagrams. When I run the program, when I run the simulation, I got this out. Then I had discussed about applications. What are the applications of this? That's all about this topic. Thank you, hope you understood that. Thank you.